There's this incredible process that's been going on for billions of years. It's a journey that connects the highest clouds with the deepest oceans. Today, we're going to follow that amazing, cyclical story of water. And our story is going to start small, with just one single drop of water. Now, it might look perfectly still right there, but trust me, it's about to go on an absolutely epic journey. One that's been repeating for, well, billions of years. So, how does this all get started? Well, it begins with an event that I like to call the Great Escape. All right, so the very first stage of this journey is all about a transformation, turning from a liquid into something else entirely. And the engine driving this whole thing? The massive, invisible power of the sun. This first step has a name you probably know: evaporation. Basically, the sun's heat gives our little water molecule so much energy that it just breaks free, transforming into an invisible gas called water vapor. It literally becomes lighter than air and starts to rise. And the sun has a massive playground to work with. A staggering 71% of our planet's surface is covered in water. Every single ocean, every lake, even the tiniest little puddle is a launch pad for this journey. So, as our molecule rises up and joins countless others in the atmosphere, it becomes part of what we feel on a really muggy day. We call that humidity. It's just the total amount of all that invisible water vapor floating around in the air. Now here's what's fascinating. There's this direct relationship between temperature and how much water the air can hold. Think of warm air as a giant, thirsty sponge. It can soak up way more moisture than cold air ever could. But, every sponge has its limit. So what happens when that atmospheric sponge gets completely waterlogged and just can't hold one more molecule of vapor? Well, that's when we hit a critical moment, the tipping point. It's called the dew point, and it's way more than just a term you hear on the weather report. It's the exact temperature where the air becomes 100% saturated. At that point, all that invisible water vapor has no choice but to become visible again. And this transformation back into a liquid is called condensation. Now, it can happen in a few main ways. Maybe it's air touching a cold surface, like the side of your glass. Or it could be warm air rising way up high into the atmosphere and cooling down. Or you could have two different air masses that just collide with each other. But the trigger is always the same: cooling down. So let's take a look at the beautiful and sometimes pretty eerie forms this condensation takes when it happens down here, close to the ground. First up, we've got dew. As the ground cools down overnight, the air touching it also cools, and eventually, bam, it hits its dew point. Our water molecule is forced to condense, leaving behind those tiny little jewels of water we see sparkling on leaves in the morning. But if the surface temperature drops below freezing, something totally different happens. Our water molecule actually skips the liquid phase completely. It goes directly from an invisible gas into these delicate, beautiful ice crystals. And that, of course, is what we call frost. So what happens when an entire layer of air cools down all at once? Well, we get fog or mist. And they're both pretty much the same thing, a cloud that's touching the ground. The only real difference between them is density. We call it fog when you can't see very far, and mist when you can see a little bit further. That key cutoff point is 1 kilometer. Once visibility drops below that, it is officially classified as fog. It's a powerful reminder of what happens when a huge blanket of air cools to its dew point all at once. But the journey doesn't always stop near the ground. What happens when our water molecule keeps rising, going higher and higher up into the atmosphere? Well, that's when it forms clouds. Billions of these condensed water droplets or ice crystals all gather together to create these incredible floating structures. We classify them based on two main things: their shape and how high up they are. Way up high, we're talking 8 to 10 kilometers, you'll find cirrus clouds. It's so cold at that altitude that they're not made of water droplets at all. They're made entirely of ice crystals. And that's what gives them that signature wispy, feathery look. They usually signal fair weather. And then there are these guys, the ones everyone recognizes. Cumulus clouds, the classic puffy, cotton-like clouds we all see on beautiful sunny days. They're much lower in the atmosphere, just kind of dotting the sky. So our molecule has evaporated, it's condensed, and now it's just hanging out in a cloud. But you know the saying, what goes up must come down. Sooner or later, it's got to complete its journey and head back to Earth. First, you've got convectional rain. This one's really dramatic. The sun just intensely heats the ground, causing a column of warm, moist air to shoot upward.
As it skyrockets, it cools, forms these huge, towering clouds, and then unleashes these really heavy, often thundery downpours.
The second type is orographic rain. This is what happens when moist wind runs into a mountain and is just forced to rise. As it goes up, it cools and drops all of its moisture as rain on that side of the mountain. This leaves the other side, the leeward side, totally dry in what's called a rain shadow.
And finally, there's cyclonic rain. This happens at weather fronts, where a cold, dense air mass acts kind of like a plow, forcing a warmer, lighter air mass to rise up over it. This gradual lifting process is what creates that slow, steady, and widespread rain.
So our single drop has completed its journey. From an ocean to an invisible gas, from a jewel of dew to a castle in the sky, and finally all the way back to Earth as rain.